Hello friends, welcome back to your UPSC. So today in climatology we will be completing our second part of humidity and precipitation. So let's get started. So here in precipitation we will be first covering fogs. Fog are actually special type of thin clouds. They consist of microscopically small water droplets which are kept in suspension in air near the ground, and they reduces horizontal visibility. Okay, so what exactly happens is, this is the ground, and near the ground we have air present. Okay, and this air, it is consisting of very small tiny air droplet tiny water droplets. Okay, water vapor droplets which are freely suspended in air. Okay, and these air droplets, they are actually near to the ground and they reduce our horizontal visibility. That means if we are standing here, then we can't see the object placed here. Okay, so our visibility is reduced. Okay, now what are the basic characteristics of fog? So the first basic characteristic is, it is formed due to radiation, conduction and mixing of warm and cold air masses near the earth's surface. Okay, so the first is, they are formed due to radiation, conduction and mixing of warm and cold air masses near the earth's surface. So how they are formed? By radiation conduction, that we will study later. Okay, the next point is, they are formed when the moist air means having the relative humidity more than 97%, okay, becomes saturated. So the moist air, when it becomes saturated, it reaches its dew point, and even after reaching its dew point it further cools down so that the water vapor is condensed around the dust particles. So these dust particles like smoke and all, they are known as hygroscopic nuclei. Okay, and they form tiny droplets. Okay, they form tiny droplets. See, if there is bigger droplet, it will fall down. Okay, they form such tiny droplets that are suspended in air, being very light. Okay, so they are light and they are suspended in air. Next is, if we have light fog, okay, then this light fog is called mist. And there is a term, smog. I think all of you must have heard this term, but let's discuss this term. Actually, smog is, it arrives from two words, mixing of two words, that is smoke plus fog. Okay, so this is actually found in winter season in urban cities. Okay, so here what happens, the fog, it mixes with smoke and the clouds are formed. These tiny clouds are formed, thin cloud layer is formed, and this cloud layer is known as smog. Okay, and it is very bad for health of human beings, animals, etc., etc. Next is, fog is associated with inversion of temperature and occurs in morning hours due to, okay, sorry, it occurs in morning hour but also continues till noon. Sometime it continues till noon, and it occurs during morning hours, and it is associated with inversion of temperature. Okay, and what are its extent? In subtropical region it occurs during winter season only, while in the region beyond 35-degree latitude, okay, beyond 35-degree latitude, that is temperate region, it occurs in all season. that is throughout the year. Now, we have classification of fogs. So the classification, fogs are classified on various type on the basis of their visibility, on the basis of their origin, etc., etc. But basically we have listed amount of fogs. Okay, so the first one is radiation fog. Now, the first one is radiation fog. In radiation fog, what happens is we have cold ground, and above this cold ground we have warm and moist air. Okay, so this warm and moist air, in this situation what happens, this warm and moist air, due to cold ground, it reaches its dew point. Okay, and because it reaches its dew point, the condensation of water vapor starts. So the condensation of water vapor starts, and these water vapors are accumulated along or around hygroscopic nuclei. Okay, and forms numerous tiny droplets, and these numerous tiny droplets, they together are known as fog. Okay, but for the formation of fog there are certain conditions required. First is we should have long and cool winter night. Second is cloudless sky. Third is sufficient amount of moisture should be present in the air. And the fourth is the ground inversion of temperature. Okay, so this was radiation fog, and this type of radiation fog, it is commonly found in urban areas. Why it is commonly found in urban areas? See, because we have abundant amount of smoke, and because we have smoke is hygroscopic, and because it is hygroscopic, it collects abundant amount of water vapors are collected on it during such conditions, and they are some they forms smog. And sometimes what happens is these particles, these hygroscopic particles, they are formed of poisonous gases like sulfur dioxide, etc., etc., and these gases are really injurious to health of human, and they causes death also because they are poisonous. Okay, and this type of fog is known as urban smog. Okay, so urban smog is formed when we have smoke particles such as uh, sulfur dioxide, etc., which act as hygroscopic nuclei. Okay, and around them the tiny droplets of water are collected and fog is formed. Now next is advectional radiation fog. Advectional radiation fog, it is formed due to mixing of warm moist air and cool air or cold air. Okay, now what happens is this is a cold ground, and because it is a cold ground, the air above it will also be cold. But now what happens is warm and moist air comes from somewhere. Okay, and it comes towards cool air. Now, because the warm and moist air is coming, it mixes with cold air. The cold air mixes with warm and moist air, and here the advectional fog or advectional radiation fog is formed. How it is formed? See, this warm and moist air, as soon as it mingles or it mixes with cold air, the particles or the water vapors, they condenses and they form tiny droplets. Okay, and thus the radiation advectional radiation fog is formed. Now, for the formation of this type of fog, there are certain conditions that are required. First is horizontal movement of air. Obviously, horizontal movement of air is required because the warm, moist air has to come from somewhere. Okay, and for that, we need to have a movement of air, that is horizontal movement of air. Second is greater contraction or greater contrast between air temperature. So the cold air must be very cool or the warm air must be very warm, so that there is greater contrast in the temperature of the air, and the greater the contrast of the temperature of air will be, the more fog will be formed. Okay, next is moist air or say high relative humidity in air. The air should be moist or there should be high relative humidity in the air. Then lastly, we should have a stable stratification in the atmosphere. So now when these conditions are fulfilled, advectional radiation fog will be formed. Now we have next term related to advectional radiation fog, that is sea fog. Now in sea fog what happens? First of all, it is formed near the coastal region where in the sea, cold currents occur or cold currents come. Okay, and because we have cold currents here, the temperature of the sea will be cold. Now, when the air from the coastal area it comes towards the sea, here we have moist and warm air. As it comes towards the sea, because it is having cold temperature, this air will condense, and due to condensation, fog will be formed, and this type of fog is known as sea fog. Next we have steam fog. It is also known as evaporation fog. So the steam fog are advectional fog which are formed when the cold air moves from the land over the oceanic surface. Okay, so here it is oceanic surface, and now the cool air is moving towards the land. And now, as this cool air comes over this warm sea is having quite a large amount of evaporation. Okay, and there is large quantity of moisture in the water surface so that it can saturate the above laying cold air. Now, in such situation what happens is the overlaying cold air is warmed. How it is warmed? It is warmed from these vapors or this heat which is coming from below, and thus the water vapors are formed, and thus water vapors, due to evaporation of water. Okay, so here we have sea from which the water vapors are rising. Okay, and these water vapor, what happens is these water vapor, they warm the above laying cold current, and these warm water surface these warm water vapors, they actually meet the cold air and they form fog. As these water vapor, they also condenses. So due to warm condition, due to cold condition in the upper atmosphere or air, what will happen? This warm water vapors, they will condense and the fog will be formed. Okay. So the various particles or the vapor particles above the water surface looks as if the steam is coming up from the water. Now as these particles or as these water vapors which are rising, they condenses, so it will look like these water vapors are like steam which are coming from the water surface, and hence this type of fog is known as steam fog or evaporation fog. Okay. Next we have upslope fog or hill fog. These upslope fog or hill forms are formed near the or on the hill slopes, along the hill slopes. Now what happens is we have warm and moist air, continental moist air, which comes, and because we have this barrier, it has to raise up, and as this air rises up upslope along the hill slope, okay, what happens? The rising air, it becomes saturated because of cooling and condensation of, so the moisture, it gets collected around the hygroscopic nucleus present here, and the fog is formed in the lower segment of hill slopes. Okay, so here fog will be formed. Now this condensation or this fog is formed due to adiabatic expansion and cooling. Okay, so how adiabatic expansion and cooling? See here, the heat, there is no exchange of heat or energy is taking place, only because the air is rising and it is expanding. Because of its expansion, it is cooling down, and this type of cooling down or this type of process is known as adiabatic process. Okay, and such type of fogs are common in hill slopes of temperate region. Next is frontal fog. Frontal fog, as the name suggests, it is formed by the collision or convergence of two contrasting fronts. So we have warm and moist air front which is raised up by cold air front. Okay, and as we have cold air front underlying cold air front, the overlaying warm air front, it condenses or it cool downs because of this cold air front. Okay, and because of its cooling down, fog originates due to its condensation. Okay, and this type of fog is known as frontal fog, and they are formed in temperate region. Now sometime what happens, when the saturation and condensation of the overlying warm and moist air, it actually causes rainfall. Okay, this condensation causes rainfall, and because of this rainfall, the underlying cold air mass is saturated and thus the fog is produced. Okay, so because of condensation and rainfall, the underlying cold air mass is also saturated and the fog is produced. And this both these type of fogs formation is known as frontal fog. Okay, now as we have done fog, we will come over to clouds. Clouds are actually aggregation or they are aggregates of innumerable tiny water droplets, ice particles, or mixture of both in the air, generally above the ground surface. So, fog was near the ground surface, but it is above the ground surface, and here we can see water droplets or ice particles or both of them. Okay. Now, they are formed due to condensation of water vapor around the hygroscopic nuclei. So water vapor, it condenses around the hygroscopic nuclei. Why these water vapor condenses? Because of cooling. And this cooling is a result of lifting of air. Okay. And this type of cooling is known as adiabatic cooling. Okay. Now due to adiabatic cooling, water vapor are formed. Water vapor condenses and they get collected around the hygroscopic nuclei. This is how the clouds are formed. Now after we have done formation of clouds, we will look into classification of clouds. So the clouds are classified on the various type, but according to their height, they are classified into 4 families. Okay. So the families are high, middle, and low clouds, and the cloud of vertical development. Okay. So the Cumulonimbus Cloud is a cloud of vertical development. So the first one is high cloud. High clouds, they are formed at the height of 6 to 20 kilometers above the ground. So the first type of cloud is cirrus cloud. Cirrus cloud, they are actually high altitude detached cloud. They are like this. Okay. So they are fibrous. Okay. And they are hair like, we can say, having silky appearance. And these are formed of tiny ice crystals and are transparent or white in color. They are containing tiny ice crystals. They may be transparent or may be white in color. And the brilliant color that we see, so the brilliant color during sunset and sunrise. So during sunset and sunrise, these cirrus cloud, they have brilliant color. Okay. The color that we see in the sky is because of them. These clouds are actually, they indicate dry weather conditions. Okay. So they indicate dry weather. Now, next is cirrocumulus clouds. Cirrocumulus clouds are white color clouds having cirriform layer or patches of small white flakes. Okay. Now, they generally appear like ripples. So, small white flakes, we can say, and they appear like ripples. Okay, what are ripples? Ripples are landforms that we have studied in desert landforms, desert topography. Okay, but they are not common type of clouds. Next we have cirrostratus clouds. Cirrostratus clouds, they are generally white in color and they spread in the sky like milky thin sheet. Okay, and they are like thin white veil. Okay, of cirrus cloud. They are composed of tiny ice crystals that reflect the light of sun and moon. Now, because of refraction, what happens is this is sun. We can see halo around sun and moon. Okay, so halo around sun and moon are formed due to cirrostratus cloud. Cirrostratus cloud are transparent so that the sun and moon are visible through them. Next we have middle clouds. Middle clouds are actually 2.5 to 6 kilometers above the ground. So the first type of middle cloud is Altostratus Cloud. Altostratus Cloud are thin sheet of grey or blue colored having fibrous or uniform appearance, and they become thick sheets in the sun and the moon. So they are thin sheets, okay, thin sheets of grey or blue color, but they become thick sheets. Why they become thick sheets? The sun and the moon, they are obscure and they appear like bright spot. See, we can see that like this they become thick sheet. So the sun and moon are not directly seen, only the spot, their spot is seen or their light is seen. They don't appear because of these clouds. And these clouds don't form halo around the sun or moon. They cover the sky partly or totally. Okay? And they are smoothly distributed over the entire sky. And they cause sometimes cause drizzle or snow. So drizzle or snow are formed or are caused due to these type of clouds or altostratus cloud. Next we have alto cumulus cloud. They are characterized by wavy layer of globular form and they are fairly regular pattern of line group of waves. Okay, so they are like now actually what happens here is they are individual masses of cloud that are fitted closely together in a geometric pattern, and the high globular group of altostratus are sometimes called as sheep cloud or woolpack cloud. So what happens in it is these are these we have pattern of line group of wave. Okay, now these this is a single cloud, this is a single cloud. They actually collect, so they appear like sheep cloud or woolpack cloud. Okay, next we have nimbostratus cloud. Nimbostratus cloud, they are low clouds of dark color and they are very close to the ground surface and they are completely dark. Okay, there is complete darkness and they actually, what is the meaning of nimbo? Nimbo means rainstorms. So they are associated with rain, snow, sleet. Okay, but these nimbostratus cloud, they are never accompanied with thunder, lightning, or hailstorm. They simply cause rain, sleet, or snow. So the nimbo, it is formed from the word nimbus. Nimbus means rainstorm. Lastly, we have low clouds, which are about 0 to 2.5 kilometers above the ground. So the first one is Stratocumulus Cloud. Stratocumulus Cloud is grey or whitish in color. They are found in round patches between the height of 25,000, 2,500 to 3,000 meters above the ground. Okay, and they are composed of globular masses or rolls. Okay, and these globular masses, they are generally arranged in the form of line or waves, and they are associated with fair and clear weather, but occasionally we can find sometime rains and snow. Next we have stratus cloud. Stratus clouds are dense, low-lying fog-like clouds in the dark gray color. They are fog-like clouds and they are low-lying and they have dark gray color. They are composed of several uniform layers, and these clouds are associated with rain and snow. They are called nimbostratus cloud. Now we have nimbostratus cloud. Now when these clouds are associated with rain and snow, they are called nimbostratus cloud. Okay, these stratus clouds, when they get associated with rain or snow, they are known as nimbostratus cloud. Next we have cumulus cloud, that is the last one in low clouds. These cumulus clouds are, they are dome shaped. Okay, they are dome shaped, and here what happens is they have flat base and they are dome shaped. Okay, they are composed of white wool packed clouds masses, and they are associated with fair weather. They are generally associated with fair weather, but sometimes they become thunder clouds also. Okay, lastly we have this vertical family of cloud, just like this. These type of clouds, they are known as cumulonimbus clouds. So these cumulonimbus clouds, they show great vertical development and they produce high rainfall, snow, hailstorm, and these hailstorm, snow or rainfall, they are accompanied with lightning, thunder, gusty winds, etc. etc. Okay, unlike nimbostratus clouds or stratus cloud, they are associated with thunder, lightning, etc. So these were the types of clouds. Now we will look into rainfall. So rainfall. Rainfall is actually the presence of warm, moist and unstable air and sufficient number of hygroscopic nuclei. These are the prerequisite for formation of rainfall. Rainfall is a type of precipitation only. Okay. So we should have warm air, moist air, unstable air, and there should be sufficient number of hygroscopic nuclei for the formation of rainfall. Now what happens? The warm air is lifted up and it becomes saturated. As it becomes saturated, clouds are formed, And these clouds, when they condenses, okay, and the air which condenses should be super saturated. So when these super saturated air it condenses, it causes rainfall. Okay, so now we have a term known as cloud droplet. So the cloud droplet is actually, they are the droplets which are formed when the water vapor they condenses and they settle around hygroscopic nuclei. Okay, so what is the difference that it is called as cloud droplet? See what happens. Firstly, the air rises with a dry adiabatic lapse rate till the condensation level, and after the condensation level, as they saturates, their latent heat is released, and because of the release of latent heat they rise furthermore. Because they are rising furthermore, they rise at the rate of they rise at moist adiabatic lapse rate. Okay, now when these droplets are formed, these droplets they accumulate around the hygroscopic nucleus, and these droplets are known as cloud droplets. Now rainfall occurs when these cloud droplets are converted into, or they change into, raindrops. Okay, now there are two possible processes by which the cloud droplets can change into raindrops. Okay, so the first process is if the warm and moist air ascends to such a height that the condensation begin below freezing point, then both the water droplets and ice droplets are formed. The water droplets are evaporated and become difference. And because of difference of the water pressure, so because of difference of vapor pressure between them, the ice droplets, see, we have water droplets or warm or moist air which ascends to the height, and it ascends to such height that its condensation begins below freezing point. Okay, then both the water droplets and ice drops, so we have water droplets and ice drops, they are formed. Okay, and now the water droplets are evaporated because of difference of vapor pressure between them and the ice droplets, and there is condensation of evaporated water vapor after the ice crystals, which goes on increasing in size. Now as they go on increasing in size, and if they become sufficiently large in size, they cannot be held suspended in the air, because of which the raindrops are formed and they fall down on the ground. Okay, in the form of raindrops. Second is, this was the condensation below freezing point. Second is the suspended cloud droplets. These cloud droplets in the clouds have different size. Okay, the cloud droplets when they collide among themselves at at the varying rate due to difference in their size. So these are small droplets, and when they will augment with each other, they will form a larger droplets. So a limit will come when we will have such a large droplet that it can't be held suspended, and when this limit will come, they will come down. Okay, they will fall down in the form of raindrop. Now this was the formation of rainfall or formation of raindrop. Now we will look into the type of rainfalls. So we basically have three type of rainfall. First is convectional rainfall, second is orographic rainfall, and third is cyclonic or frontal rainfall. So the convectional rainfall, here what happens is the principal motivating force behind this ascent of warm air and moist air is thermal convection. So because of thermal convection, in thermal convection what happens is this is a ground and this ground is warm ground or hot ground surface, and because this is hot ground surface, due to thermal convection the moist and warm air is heated up, and this because it is heated up it rises, and as it rises it forms cloud. Okay, now this was a simple mechanism. Now but for this convection there are two conditions that are required. The first is abundant supply of moisture through evaporation of air so that the relative humidity becomes high. So now when there is abundant moisture which is supplied through evaporation, so the relative humidity will be very high to make the air supersaturated. Okay, now the ground should be intensively heated. Okay, as the ground will be heated, because the amount at which the ground will be heated or the heat energy of the ground will only make the air heated up, and because they get heated up they will rise. Okay, so these are the conditions required for convectional rainfall, and that is how convectional rainfall occurs. So in it we can say simply what happens is during daytime sunlight comes, and the sunlight it heats the ground surface. So when this ground surface is heated up, the warm air which comes in contact with this ground, it also get heated up, and because it get heated up it rises. Now this ascending warm and moist air cools according to dry adiabatic lapse rate, that is 10 degrees Celsius per 1000 meters. Okay, so this is still condensation level. Okay, the moist air soon becomes saturated. Now as it saturates the latent heat is released. Okay, and because of which it further ascends. Now as it is ascending beyond the condensation level, here what will happen, cumulonimbus cloud will be formed and the rainfall will start, but the air still continues to rise, and now the process now in this process it will further cool down. Okay, but now its cooling will be at the rate of moist adiabatic lapse rate. Okay, that is 5 degrees Celsius per 1000 meters. Why? Because latent heat energy is added, because of which this air rises up at the moist adiabatic lapse rate. Now this ascending layer air, it reaches the height where the temperature matches with the temperature of the surrounding air, and as it reaches the height the process of condensation it starts. Okay, and here also cumulonimbus clouds are formed. So the clouds are formed. See, now these clouds will give more heavy rainfall than the clouds that were formed below. Okay, so that is convectional rainfall, how it occurs. Now we will look into various features, characteristic features of convectional rainfall. First, it occurs every afternoon in the equatorial region. So in the equatorial region, because of intensive heating of ground by the sunlight, the air rises up, and the rising up air, it condenses and forms the cloud, and these clouds give rainfall. It occurs through thick, dark and extensive cumulonimbus cloud. So here cumulonimbus clouds are formed. These are cumulonimbus clouds. Okay. It is accompanied by cloud thunder and lightning. So along with rainfall, we can hear thunder and lightning also. Now, convectional rainfall in equatorial region, it supports evergreen forest. Okay. Lastly, convectional rainfall in hot desert is not regular but is irregular and sudden. Now this was all about convectional rainfall. Now we will look into orographic rainfall. Orographic rainfall, as the name suggests, it is the rainfall that is caused due to upward movement of air, okay, on the hill slope. So the orographic rainfall, it occurs due to ascent of air forced by mountain barrier. Okay, so this is mountain barrier. Now the air is ascending, and this air which ascends along the mountain slope is lifted up. This air mass cool downs due to dry adiabatic lapse rate. Okay, according to dry adiabatic lapse rate, and with the increase in relative humidity of the air, it cools down and condenses. Okay, because this air becomes saturated. So the condensation begins around the hygroscopic nuclei here. Now, as the condensation begins, the latent heat of condensation is released, which causes the air to rise further. But now with moist adiabatic lapse rate, okay, so thus the ascending air, it continues to yield precipitation with the increase in height, and it appear and it appears that the mountain barrier, that triggers the effect of moist air to ascend, cool down and become unstable, okay, and hence the rainfall occur. Now we have two terms related with this type of rainfall. Now the side at which rainfall occurs is known as windward side or onward side. It receives maximum rainfall. But now what happens, as this air has lost most of its moisture by raining in this side of the slope, as it comes down here, what happens, this region, it receives lesser rainfall. Okay, and this is known as leeward side or rain shadow side. Okay, so this is windward side and this is rain shadow or leeward side. Now there are various conditions which are to be fulfilled to have orographic rainfall. First of all, the mountain ranges should be closely packed, and they should not be parallel to the wind direction. They should be obstructing the wind direction. Okay, That is, they should be against the wind direction. So like we have Aravallis. Aravallis do not get rainfall because they run parallel to the wind direction, while the Himalayas, they get rainfall because they are obstructing the pathway of the wind. Next is they should be closely packed and they should be parallel to the sea coast, like we have Western Ghats. Okay, so the Western Ghats are parallel to the sea coast. So as the warm and moist air comes and as it strikes the Western Ghats, we have rainfall in the west side of the Western Ghats. Okay. Next we have the height of the mountain. They also affect the rainfall or the amount of orographic rainfall. Why? The more the height of the mountain, the more the air will rise and more it will condense and the more the rainfall we get. Okay. Next we have the air should be having sufficient amount of moisture. See, if the air is coming from the sea, then it must be having good amount of moisture. But if the air is coming from the land, then it won't be having moisture. So if it rises up also, then also we can't get a good amount of rainfall. Okay. Now as we have done orographic rainfall, now we will jump over to cyclonic or frontal rainfall. So the cyclonic or frontal rainfall, as the name suggests, they are formed or they are caused due to formation of front. Now in this what happens is we have rainfall that is caused due to ascending of moist air. Okay, so here we have cold air and here we have warm air. So this warm air ascends. This warm air is containing moisture. It ascends and it cools down due to expansion or due to adiabatic cooling. Okay, so when these two contrasting air masses they converge, the warm air is uplifted and this warm air it cools down due to adiabatic cooling. And as this air mass cool downs, it condenses and similar way like what happened here, clouds are formed and rainfall it occurs. And this type of rainfall is associated with temperate cyclones. Now in temperate cyclones what happens is the warm air mass it converges with the cold air mass and this cold air mass it occludes the warm air mass. Okay, the warm air mass is uplifted and with this when it is uplifted clouds are formed due to ascending and condensation and rainfall occurs. Okay, so that was about rainfall. Now we have other form of precipitation. So the first form of precipitation is snowfall. Snowfall is actually they are fall of larger snowflakes from the clouds on the ground surface. So large snowflakes they fall on the ground and this is known as snowfall. Sleet is actually mixture of snow and rainfall. So rainfall also occur along with snow. So here what happens, we have transparent or translucent ice that falls down and this ice is having the diameter of less than or equal to 5 millimeter. Next we have hail. Hail, they consist of large pellet of or sphere of ice. And this is solid precipitation wherein small balls of pieces of ice known as hailstones, they fall. Okay, and they are very destructive and they degrade the soil form. Okay, what we call as ola in Hindi. These are hails. Lastly, we have drizzles. Drizzles are fall of numerous small and uniform minute water droplets having the diameter of less than 0.5 millimeter is known as drizzle. Okay, so small, various small uniform droplets they fall, they are known as drizzles. So these were the type of precipitations. Now we have completed this lecture on humidity and precipitation. So that was all for today, guys. I hope you enjoyed today's lecture. Let's meet in our next class. Till then, take care and have a nice day.